Hello, everyone. Welcome to this week's Bounty episode of the Day Zero podcast. Just as a reminder, this is the first part of a now two-part podcast, so we will be back tomorrow at 7 p.m. Eastern, 12 p.m. Pacific, going into more of the binary and research type topics. And that is also when we will cover the Spot the Vuln solution for the challenge we had up on the pre-stream, for those of you who are looking at that. Before we get into the topics, Z, you wanted to bring up something you've been working on with the site, with the vulnerability page.
Yeah, it's just kind of with us splitting up the podcast. Part of that has been to provide a podcast that's perhaps a little bit more useful to people, a little bit more digestible. And alongside that, I've been working on this vulnerabilities page on our website here, day0sec.com/vulns. Um, all it is basically while we're working on the episodes, we write up our own summaries for our own notes. So I've started making those accessible here, searchable. So you can find, when we've talked about cross-site scripting or whatever. It's not all of the summaries from all of our past episodes. I think I got summaries from like our past 5 episodes, so last week, and then a few of our older ones. I just want to mention that that's kind of there now and available. And that kind of goes with the podcast too. All of our podcasts now have those same summaries available too, in case you don't actually want to sit through everything.
Or if you just want to refer back to something later, right?
Yep.
It's all right there in writing for you. So, um, yeah, I just wanted to offer a little bit more value with some of the stuff that we cover. All right, so let's jump into our topics. We'll start off with some news and drama around a bug that was thought to be a post-auth RCE for Atlassian Confluence. Won't go into the bug too much specifically since it is older. It was reported back in August, but it was an object graph navigation language injection. Um, so these researchers claimed that they went and investigated it, and they found that it was actually a pre-auth RCE. It was thought to only be a post-auth RCE before. So they tweaked their payload. They were testing it on VMware, and they had to get through VMware's web application firewall rules for Confluence. There were some things like they checked if there was like an eval keyword or something used. So they just had to use some tricks to get past the firewall, and they successfully exploited it. So when they managed to get it working, they reported their findings to VMware security email, and around a day later, someone else submitted according to them, 100% identical payload to a different project, being Nuclei, the vulnerability scanner for project discovery. So they go into some of the details of the timeline, as well as the payload parts and how they're identical and specific to the VMware payload. Mainly what they needed to do to bypass that firewall, like using Unicode escape strings to avoid the eval
I
keyword.
mean, they include that, but I just want to jump to the point here. The point is VMware apparently leaked this. I don't really doesn't really matter too much about what the details are of the actual attack. There is a published RC on it. Sorry to just kind of cut you off on this, but like
Yeah, no worries.
I just want to jump and get that out of the way that the issue here is VMware apparently leaked this vulnerability to the Nuclei project after it was reported, and these guys obviously have an issue with it. I don't know how I feel about it. How do you feel about the idea that VMware had a bug reported to them, and then they took the payload for that bug and reported it elsewhere?
Okay, so I just want to clarify something. Did VMware do this directly? Because the way that
We
I
don't
read
know. It
this,
just appears to be that way. I would say like that's where they get into talking about the bypass that they had, because they used that particular bypass because it was against VMware's WAF, and that's something they were able to detect in this payload and Nuclei project, a vulnerability scanner. In the payload there that it knows about, it used that same WAF bypass, which kind of indicates whoever wrote the entry here for Nuclei probably was looking at the VMware version of it. So we
so
don't know it was VMware. I mean, it most likely, I'd imagine this is just some random engineer at VMware who had access, saw that, and then used it on the other project.
so that's what I was thinking. What I was thinking was VMware as a company probably didn't leak this intentionally to the Nuclei project. It was probably like a rogue employee or something. That was kind of where I was thinking. Um,
That's kind of what I was thinking too, but I still don't think it's a big deal. I mean, as soon as you fire off an exploit at somebody, you should expect it to get propagated to other defenders. They tend to hold at the end of the report. Um, where is that? Yeah, the exploit we sent to VMware is our copyright property, and we did not grant VMware the right to redistribute.
so
It's a HTTP request. I don't know if I entirely agree. It's a weird area because like it is a creative request, like it is something new that's been created. I don't know if copyright applies here.
so I will say you're saying that as soon as you fire off the exploit, you should kind of assume that to be gone, like it's no longer yours. I don't know if I entirely agree. The fact that the payload was seemingly carbon copied, I think that is kind of like in bad faith a little bit to use non-public exploit payloads and report them as if you found them. I do have a problem with that, and that just might be because of you know my personal stance on just like if somebody shows me an issue that they found, I'm not going to go and report it as if I found it. You know what I mean? I'm not going to report it on like I'm not going to take action on it on behalf of somebody else.
Well,
Um,
I mean, in this case, this is a known CV that they discovered, okay, it's actually pre-auth, so they can use in some extra places. Usually, I don't know what VMware's bounty policy actually is, but usually, I mean, known CVs against, their components usually are not actually paid out. I mean, a lot of bounties, some will, or some will have like 30 days after the CV or after it's been disclosed, then they have 30 days to actually patch. Um, so I don't know where VMware actually stands on that one in particular. But when you're saying if somebody reports to you a vulnerability, like I feel like that's a little bit different since we're both kind of on the offensive side. Whereas, this also could have been somebody who wasn't even on the mail chain and saw it get reported. This could have been a blue teamer who saw the attack come in, saw the logs from it, and was like, here's an ongoing attack. Let's add the vulnerability out. Like let's make it known. And that absolutely should happen for any blue team. I mean, not all blue teams will share information like that, but sharing information about ongoing attacks isn't exactly a bad thing, especially when it's something that hasn't been seen before, or at least not publicly.
yeah, I can kind of see that perspective where it's a little bit different when you're talking about like a vendor compared to just like another researcher. It is a little bit of a different situation.
Yeah, like if
Um,
somebody reached out to me with an ODA personally, they're probably, sharing it with me so I can give them some feedback or we can talk about actually approaching the exploit. That's different. That's kind of shared in confidence. I feel like vulnerability reports are actually firing a vulnerability off against any sort of target just isn't really done in confidence, and I'm not sure that an HTTP request actually counts as like copyrightable.
Yeah, so personally, this does still kind of rub me the wrong way. It is a little bit. It seems a little bit sneaky to go behind the researchers and just use it.
I'm not
And
sure would have been like
if they did intentionally leak it, I'm not saying that is what they did because we don't know. But
yeah, like I don't
it
think this was VMware. It's just yeah, sorry, go on.
but to me, it does rub me a little bit the wrong way. That said, when you're talking about the copyrighted aspect, that's where I kind of want to jump off the bandwagon a little bit, I guess, because I feel like you're going to have a very hard time trying to like back that up, trying to make like a copyright claim on that, um,
Yeah,
because
specific.
like I don't think there's any precedent for that, and it's just it seems like a long leap to go to that. Um,
Yeah,
so
like
yeah, I feel like that was a little bit hyperbolic, but
if they wrote like a Python script that exploit the vulnerability, that Python script I think could easily be copyrightable, and if that were getting shared around, but just the end resultant HTTP request, it feels different to me. I'm not a lawyer, so I don't know exactly how that would sound, but I'm not sure That would be or it would actually fall under copyright. But yeah, when it comes down to like VMware sharing it, I could understand some thoughts of secrecy, but you're reporting a vulnerability. Why do you need the secrecy? Is one case. Like, I mean, the vulnerability you're reporting, in theory, you're supposed to be, an ethical hacker, or whatever terms you want to use for that.
Well, I don't think
You're
it's as much about keeping it secret as much as it is feeling like they got some of the valor stolen from them. I guess for their research and their payload. I think that's kind of where it comes into play is that hit to the pride, I guess. Which, to be fair, I can somewhat understand. Um,
That I
I
can
think it's more on
understand.
that.
That's actually a good point. Or at least like having some sort of coordinated disclosure. As researchers often expected to kind of bow to whatever the company wants. Would be nice if the same respect was shown in return. That is a fair point that I hadn't considered.
Now, another thing I thought was interesting towards the end is the response, because where the researchers were upset, they actually emailed VMware about their grievances,
I
saying that,
just want to cut you off and apologize to our listeners for the poor audio at the start. They were able to hear you, but I believe there was a little bit of an echo. That was threw up on my side.
oh, okay, no worries. Um, yeah, so there was a bit of a back and forth between VMware and these researchers. They reached out saying, we're not happy about this. This was kind of our research. VMware responded saying that there was a public POC that was posted on GitHub on September 1st from another set of researchers, and it must have came from there, which is pretty weird because they kind of break down why that response doesn't really make sense, saying that GitHub POC does not use the same payload as the one that they submitted, and it was also posted a few hours after the report was submitted to Nuclei. So he couldn't have gotten it from that. Like the person who submitted to Nuclei couldn't have gotten it from that public POC that was posted because it wasn't posted by that time.
No,
So
most likely though, this is just a triager sees the thing come in and is like, "Hey, no, this vulnerability is actually already public." They probably got from there and didn't actually dig into the details. That's kind of what I'm seeing there. I'm not seeing this as somebody who really looked into the claim. I'm seeing this as more likely just a triager sees it's already public, makes an assumption.
that's fair. But it is worth pointing out because it is a little bit unfavorable to VMware, the way they responded there. But anyway, yeah, it is a really weird situation. I wouldn't want to come down hard against VMware because the points you brought up about Blue Team are totally fair points. But I can understand where the researchers are coming from. Basically, that's kind of where it sum up my perspective on it.
Yeah, no, and I think you make a really good point regarding the I guess you could say fame about him being able to disclose that, and then suddenly it's just like, oh, it's already disclosed through some other party when they may have been planning to disclose it in a particular way. That's that's completely fair. I do still kind of feel like, when it comes to actually launching the attack, once it's out there, it's out there. Um, can't really take that back.
That's a good perspective to take as a researcher. Yeah. All right. So we'll move on to some vulnerabilities for this week. We'll start off with a fairly simple one, which is bad file checking on image uploads that can allow a remote shell. Um, fairly straightforward. For uploaded images, they try to check that the file that's uploaded is actually an image by checking the file magic. But the problem is that's not really sufficient because PHP was designed to be mixed with arbitrary content. Your file doesn't have to start with PHP tags, so you could still embed PHP in the file and it would still run on the web server, so you could still get a remote shell. So, not a super complex issue, just something that uh, we've seen issues like this before where people don't think about how PHP can be mixed in because it is kind of weird as a language in that way.
I mean,
And this is just another example of that.
that kind of comes from the fact that PHP acts a bit like a full framework for the web. So you kind of see that mixing of code and data, or and the website structure and stuff like that. I'm more want to call this write out up, not because it's a really crazy cool attack, but it's a reminder that like these sorts of simple vulnerabilities still exist where people just make an assumption, yet uploading image, so just make sure that's there and don't really think about how other applications work. When it comes to scripting languages, some of them may expect the whole file, but it's not unheard of for you to be able to embed scripts within code. And this is also just a reminder about defense in depth. You shouldn't be uploading user data into like the www root in general. That would kind of be the first stage, is just like one where you upload data shouldn't be executable, shouldn't be reachable by the process. Um yeah, I kind of just felt like this was a good reminder of that sort of issue, still being there and, still think about, because this is kind of an older issue that has been seen for many, many years. Easy way to start off the episode with.
Yeah, I mean, when you look at this issue in isolation, it's easy to think that, like, if you try to get in the developer's head, like, okay, we check the file magic, we're doing a good job here. It's something that's easy to miss. And Rudamal said in chat said, yeah, was investigating random broken images on a PHP host once. Turns out the short tags incidentally ended up in the binary. Yeah, I
Side
mean that.
note, I have been reading his name as root email, and I just realized when you said it, email.
Yeah. Um, but yeah, I mean, fuzzing yourself with images basically. Root 'em all. Oh, okay, that makes sense. I didn't break apart the name. Okay, now I know how to say it. Thank you. But yeah, like you said, not a super complex issue. Just something to be aware of if for whatever reason you're allowing people to upload images. And the defense in depth comment is also a great addition there.
Yeah, I mean, uploading images into the web root is really common because it's so easy. You upload the image, put it in the web root, then you just need to know where it got uploaded to, and that's kind of going to be like your avatar file name or something. So like you definitely see that a lot. Not always executable. Like you should, if even with PHP, if you're going to do that, you run that so it's not executable. You can disable PHP in that whole folder and just have it like this is an image. Don't run PHP on it.
Yeah,
It's also kind of wasting resources when you do that, so it's good for that side of things too. But yeah, I mean it's fun to see it again, and apparently got a bounty of So their bounty number here is 5 stars. So apparently, $10,000 plus. They're saying 10 digits, 10 or not 10 digits. That would be a lot more. 5 digits. I don't know if that's actually the case, but I mean, it is remote code execution somewhere, so it definitely could be.
oh, okay. I must have missed that bounty amount somehow. Oh, yeah, I see. Because I was looking for like an actual bounty number. It's really weird seeing the number censored like that. I don't think I've ever seen a post censor the bounty amount. They usually just don't mention it if they don't want to give that information. But it's a little bit weird. But yeah, good call out. Um, so yeah, we'll move into a stored XSS in the Opera browser in a new feature they introduced called pinboards. Which, as I understand it, I don't really use Opera, but it's kind of like a bookmark type thing that you can share and add notes on, like a shareable note board, I guess. That's
Yeah,
how I
that
read
that
it
seems to be
anyway.
the case. They talk about it a little bit here. Very minor background. Just they have a screenshot somewhere. I guess not. I must have just been Googling. They do have the one example here where you can add a pin. In theory, you add like a URL to a maybe an image or a video, and you can share this whole board. And these end up running with inside of a kind of higher privilege tab, at least within Opera. They do also just exist on the web pinboard.opera.com. But in Opera, it's actually at like an Opera colon pinboards, which is similar on Chrome, how you have like Chrome colon extensions for like the extensions page. It's a higher privilege page that's actually running inside of. So the stored XSS here is somewhat meaningful, and I think we'll get to it a little bit later. I think the exploit's kind of cool that they did. The attack itself um, left me a little bit confused. So they show how items are added just with a post this slash v1 items request on pinboard.opera.api.com. So that makes sense. What doesn't make sense to me is the lack of any identifying information in this example request. Possibly they've censored it, but they don't mention that. So I don't know how Opera is actually connecting this request to a specific login and to a specific pinboard. It's just an item, it's its position and what's in it, but nothing, no cookies, nothing that actually associates that request with the pinboard that's supposed to go on. So I don't know exactly how that works. Maybe there's something with HTTP2 that's going on, like it's an ongoing session, like multiple requests. I don't know if you can do that with HTTP2. I haven't looked into the details on that, but that stood out to me as a little bit odd. As far as the access goes, again, straightforward issue. When you add a link, you have a link on there, the href, and you're just sending JSON, so you can kind of put whatever you want in that request. So you can go ahead and just include a JavaScript URL or URI. And unfortunately, when you click on these links, they are executed in a target equals underscore blank. So that means it won't execute inside of the privilege tab, but if you middle click, it will be. So this is only exploitable with middle clicking. There was a little bit more work in terms of the actual payload they use. They did notice they could use JavaScript, but they do include like this add opera.com slash single quote, semicolon, then the alert, then the actual payload. They don't talk about what exactly existed on the page for that, but I assume they're just kind of breaking out and maybe pattern matching a little bit. The act is a little bit weird, and I wish they would have explained that more. I'm curious why that in particular was necessary. Uh, Probably just has to do with how it's being parsed, but they don't actually state that. Ultimately, they get the stored XSS there with middle click. Middle click is definitely a big ask. I use middle click a lot. I think Spectre, you've started to after I told you about the power of middle clicking, but
I've
I know
joined the
you
middle race club
didn't.
or the middle click club. Yeah, I have.
Yeah, I mean, I don't think a lot of people necessarily use middle clicking.
Yeah, it's funny because we've seen XSSs before that have only been exploitable in middle click. I think the same kind of situation. I think it was in a privileged tab, and
It was on Facebook actually, if I recall that one correctly. It was like Facebook or Instagram. It was a big name web app that had so they had JavaScript on the page that would rewrite the URLs to use something else. But if you middle clicked, it would use the href where the XS
yeah,
was.
that's ringing a bell. Um, So yeah, you can get an XSS in that privileged page. The attack, they went into some detail with how they pulled off the attack. They basically used the file URI to extract file contents for like Etsy password.
And the
Um,
fact they can create tabs, so they kind of knew the window that it would be created into and could get its thumbnail. But yeah, using file URI.
Yeah, I thought their exfiltration strategy was a little bit interesting. You just kind of touched on it there, but basically, they found that while they could run JavaScript, they were a bit limited in what they could do, and they couldn't access the actual page contents of the new tab that they opened, containing like the Etsy password file contents. So what they did was they made it take a screenshot of the tab through Pinboard, and then base64 that and sent that back to the attack server for exfiltration. So yeah, I thought that exfiltration strategy was a little bit cool. It's
Yeah,
not
so did
something I've
I.
really seen with like XSS in that way.
Yeah,
So
well, XSS, I mean, it did rely, so they use the opr.pinboardprivate.get thumbnail. So this is an API that the pinboard is using in particular. And they use that to get the thumbnail of the tab. So this isn't something that like if you got access on like Chrome extensions, you might not be able to get the thumbnail. I don't think there's actually an API for doing that within the normal kind of web extensions API. So
yeah,
it was unique in that sense, and they were able to get, despite it being a thumbnail. If you watch their little video there, it was fairly readable. They could read all of the content of the Etsy password page without any real issue. So yeah, I agree. I thought it was a really cool exploit. As a vulnerability or in terms of the damage of it, because of the middle clicking, it feels a little bit off, and I don't. It's kind of implied here that a random website could make this post request because the top of this is um uh I guess it's not at the top, but there was somewhere that talked about random website being able to do this. Maybe that was just where I first saw this link. I'm not seeing it now.
Yeah, and
Uh
I'm trying to look for it and I
I
can't see
mean,
it either.
it could be a self access, which, then it's not that important. But I'm imagining the case where this post request looks like it's pretty empty. There's nothing really identifying for it. So I could imagine, an attacker's website can go ahead and make this same post request basically on your behalf, and it gets added to your default pin board. In which case, they could definitely send this out to a lot of people, and just a very untargeted attack, get it there. Somebody might middle click it. Um, it wouldn't be very suspicious to have a random link appear, but I could imagine something going on with this, assuming that's the case. But if there's anything unique in that post request, um, that really limits the impact of this ability. They did get a $4,000 bounty. I don't think we mentioned that yet.
Yeah, we haven't. So yeah, good call out. Um, yeah, I think the attack was interesting. I do wish there was maybe a little bit more information or a little bit more clarification in the write up itself. Because, like you were saying earlier, it does seem like there's some things missing, and we do kind of have to make some assumptions because um, the information isn't there for somebody who hasn't looked at like Opera pin boards. So yeah, um, but that you can get the gist of the issue with this write up for sure. It just would have been nice to get a little bit more information. But yeah, I think with that said, we'll move on to SSD disclosure for NETGEAR. They reported a vulnerability in the NETGEAR D7000 router. It is a logic based authentication bypass in the mini HTTPD binary and the firmware. So this is kind of a binary issue, but it's not like a memory corruption. So that's why we're covering it on today's episode and not tomorrow's. Um, so yeah, they go into the binary world a little bit. They talk about reverse engineering. They have a little snippet they got out of Pedra, I believe. Um, but basically, what you need to know here is they do some checking when a resource is requested on whether or not they need to prompt for authentication. And the way they do that is they have this whitelist check where for getting the share folder list, they don't require authentication. And the way they do that is they use the stir function to check if the to do equals pnpx get share folder list string is set.
Which, if you're
Um,
not familiar, stir, basically all they're using it for in this case is, does the string exist inside of this other string? That's all they're really
exactly.
doing here. Because stir isn't really exposed in languages that don't give you that C API.
Yeah. So the maybe slightly obvious problem there is what if you have that string set in there, um, but you then you just find a way to work that string in there that doesn't actually set the real to do variable. And that's where the issue comes into play, right? If you can somehow get that string worked into the request, such as through the HTTP version, it'll pass that check. It thinks it doesn't need authentication, but then when it goes to parse the real to do variable that you set, um, it'll read that and it'll bypass the authentication because the check is too naive. It doesn't check to make sure that to do is actually set to that. It just checks that the string exists. So by using that attack, you can download something like the configuration file or some other privileged page to get the password. In their case, they pointed out BRS Wiscom success, which I'm not sure why, but for whatever reason, that page discloses the current password. So
Yeah, but the
I found that a little
configuration,
weird, but
yeah, the configuration file only has the hashed password, but that success page, that needs the real one on it.
I know
Um,
it's so weird.
yeah, I thought that was weird. I love the fact that they were able to go and put, I mean, real world attack, this is rarely going to work, but the fact that they were able to go and put that get, you can notice it here. It's get slash, setup CGI, and then HTTP x equals to do equals that. The fact that they were able to put this string inside of the HTTP version, I just think that's hilarious to put it there. most of the time, like if you're actually going to attack this, you're probably going to do something like, and one to do equals this or something. So it's processed as being a different parameter. And you're still getting the string in there. But oh no, it just the reason in this case, HTTP being a line-based protocol, they just have that entire request line, and that's all they're matching it against. So that's the whole thing, including get and all that. You could probably even put it as like, get or replace get with that, but then it probably wouldn't match somewhere else in the structure where it looks for get or post. But yeah, I don't know. The fact that it was there, I genuinely found that to be a hilarious place to put it.
Yeah, the password thing was what really got me. I was like, there were questions spinning in my head, but
I'm surprised
I
that
don't know
the
what the case
config
is
didn't
for
have
that.
it in plain.
Yeah, it's weird that it's just weird that one place would have it and the other one wouldn't. Like you were saying, if there was any place you would expect the password to be in plain text, it would be the config. Now, something else I did want to call out as well is while the title suggests that this is in the NETGEAR D7000, as is the case with these routers or any of these type of networking devices, the code is shared across a lot of devices. So if you look at the affected versions, there's a lot more than just the D7000 affected here. So if you're using a Netgear router and you want to be secure against that, you might want to check the full list to make sure. But yeah, I mean, it's kind of rare that we get a binary issue that's kind of like a logic bug, where it's not memory corruption. So that was kind of cool to see. And this is a pretty straightforward attack, even though it was ultimately born out of doing like some reverse engineering in order to find the bug. So yeah, a little bit weird in that regard,
Yeah, but it is
but cool.
something that I think if you're searching for bugs, looking for those odd requests that happen without authentication, sometimes it's pretty easy, like all the static files can do it, but because we have seen this exact vulnerability before, I believe it was in a Java application where it just looked for a particular parameter being set, and if it was, it skipped authentication on it. And that was only used for like part of the setup process, so it wasn't really obvious. So, I mean, as a researcher, yeah, they found it with a little bit of reverse engineering, but this also could have been found. I mean, it wouldn't have been obvious, but I guess code review would be the easiest way to find this. I'm just thinking about it now. I was going to say you could see some of those requests and try and copy things out, but you need to know exactly what to copy out, like what the magic string is, like if it needed the end or if it did need all of it. Yeah,
You'd
it
need the
would be
structure.
hard to find with in a black box scenario. Not impossible though, especially in some of the other cases we've seen where it's closer to just the more generally just being a flag being set across multiple requests. So you can kind of make that association and work from there versus this single one. So yeah, this would be a little bit tricky, but it is an issue. I mean, keep your eyes out for.
Yeah. So GitHub workflows has come back into our episode. We have another example today of GitHub Actions workflows and how they can be dangerous. This one's a token leak through the check spelling community workflow, which is used by quite a few significant projects. They list out like Jekyll uses it, ImageFlow, some Microsoft projects like Terminal. NASA uses it apparently. So yeah, it's used by quite a few pretty significant organizations, as well as the check spelling repo itself, which means it could be leveraged to add malicious code into the workflow as well. So getting into the issue kind of comes down to three things working in conjunction with each other. Uh, for one, the workflow can be triggered by a pull request, which can be submitted by anyone who can view the repo. That is one of the most infamous actions to look out for when deploying workflows. Um, for another, the .github/actions spelling advice MD file contents gets inserted into a report by the check spelling bot, and that file is controllable by the person submitting the pull request because it contains configuration information. So that could be a malicious, like that file content could be malicious.
Yeah,
The
like
other problem is, oh
the
yeah, go ahead.
intent of that advice is literally just It'll be part of the comment before like all any of the spelling errors. It's like, here's your generic advice file that every comment just gets a starter like, yeah, you should listen to this bots report, and here are some of our standards for spelling, or like you can check this place for it or whatever. That's the idea of using this. It's just a file that gets echoed or catted into the comment that the bot leaves.
Yeah. Now, the biggest problem is you can set up a symlink on that advice file. And you can symlink that to something sensitive like the environment, like the proc self environment, or whatever I forget what the exact endpoint is, but they listed in the report.
Well,
Um,
environ, but yeah, close enough.
environ, yeah. So they can dump the environment in a report through the comment, which would include the GitHub token, among other potential secrets. Now, that token is ephemeral. It will only last as long as the workflow finishes executing. Um, like when the workflow is finished executing, that token won't really be useful anymore. But you can use it if you're quick enough and race to beat the workflow's completion. And if they win that race, they can do things like merge the pull request, create a malicious release, and then even do some stealth actions like deleting the report comment and the pull request to eliminate the obviousness of the attack being used. Um, so yeah, I mean the impact there is pretty big, because if you can create a malicious workflow and get malicious code in there, you could potentially hit other repositories that are dependent on it. Um, you kind of have that supply chain type aspect to it, and yeah, I mean, this is just another good example of why workflow developers need to be really careful with what they give access to on public repos, because they are very powerful. And by extending the workflow capability to run on something like uncontrolled pull requests, you're opening a lot of potential for damage. We've seen GitHub put out posts about this in the past. The GitHub Security Lab, they've done a full like write up of the potential dangerous things that can be done with workflows. And I mean, it's one of those things where I think we've covered a lot of the theory about how it could be dangerous, but we haven't seen too many attacks that take advantage of it. Um,
I feel
so
like we've
this is a
definitely
good example to point to. We've
we've
covered some
covered
before, but
yeah, we have covered some. I mean, this is just an example though. Like the problem here is the fact that advice can actually be pointed outside of the repository. Like it's not really doing anything sensitive with the advice file. It's just echoing it out, and you can happen to abuse that by pointing it outside of the actual repo. So the way they fixed this was they effectively just check the advice file and ensure that it lives with inside the repository and not inside of the .git folder.
yeah, so I thought the fix was a little bit interesting because the suggested fix was to just change the workflow to make sure the configuration files couldn't be symbolic links entirely, um, as well as some defense in depth, like separating the spell check performing and generation of the pull request comment from the posting of that comment. That way, generation could be done in a lower privileged context. Um, but yeah, the way they fixed it was they do still allow symlinks. They just only allow them to files within the repo, and like you said, not the .git directory, because then they could leak the git config. They are also planning to implement the suggested defense in depth of separating the actions, but they haven't done that yet. That's kind of like a left for future work kind of thing. Um, but yeah, I find it interesting they even allow the symbolic links at all. Um, because I was just trying to think in my head, like, why wouldn't they just block them outright? It seems like if I was going to fix this issue and I knew that I wouldn't need symbolic links, I would just want to disable them entirely. They're like symbolic links are just a
You
dangerous thing
don't
to leave
know
open.
that you won't need symbolic links, though. I mean, sure, everybody, you could force everybody just to use whatever your repository structure is, but I mean, another repository might prefer to store that advice.txt file with, some other a configuration folder, something like that. They might prefer to store that somewhere else.
Yeah, so that's why I thought the fix was interesting.
Well, so the
It's a
fix
fair
lets them
fix.
do that.
Yeah, I know, but that's what I'm saying is like, um, just the way they kind of struck had to strike that balance of still allowing sim links but just restricting them. Um, it just deviated from the suggested fix a little bit, and it makes sense when you think about wanting to leave it flexible for people to configure it how they want. Um, but it when I saw that, I kind of had to get into the headspace of the developers a little bit to understand why they made that fix the way they did. Um, but yeah, I mean the mitigation strategy I think was also a good add for them to put in there, um, because we talk about it all the time, but defense in depth, like if that was put in place before, even if this attack was possible and they still followed the symlinks to the environment, um, they wouldn't have really been able to do anything because the posting of the comment would have been done in a higher, like you would have compromised the lower privileged context. Is basically what I'm trying to say there. So yeah, that was a good call out too.
Yeah,
Um,
the attacking of this one is, I think, kind of interesting just because that GitHub token is very short lived and it's only sent out towards the end of the workflow. Like, that's the whole point of the workflow. So, once you make that comment, there isn't a lot left. So, it is a tight, at least I think it is a tight window, but other things can be sitting in the environment that might be used, depending on the application itself
yeah.
or other files. I mean, the whole idea here is pointing it basically anywhere like that on the runner rather than in the repo.
Um, they also posted a disclosure timeline toward the end. They first sent a courtesy notice to MSRC at Microsoft on June 21st, sent the advisory draft to MSRC on June 25th, which was then forwarded to the maintainer on June 26th. And then it was patched and updated on July 13th in V0.0.19. So I guess this is tying back a little bit to the topic we had earlier with the patch from or the payload that was submitted to VMware being submitted to the other project. I guess this is a little bit of an example of what you were talking about, C, where they forwarded it to Microsoft and then Microsoft forwarded it on to the maintainer. Um, I just thought I'd call that out because I didn't really think about it before, but since you said that earlier, it kind of clicked in my brain when I was uh, just looking at that note. So um, yeah, but yeah, not too much more to talk about there. So we'll move into creating some free Shopify application credits. So this is a report on HackerOne in Shopify, which is a popular e-commerce platform. The bug is another broken access control type issue. One of the things Shopify allows you to do through the admin API is issue credits for merchants to use for purchases in the future, such as I'm guessing for like running special promotions and whatever.
So,
Um,
this is part of the app. So there's kind of Shopify stores and Shopify apps. I don't know exactly
oh, I
what
see.
the difference
Okay.
is, but so this is for app credits. So this is for somebody who creates an app to issue to merchants that were trying to use their app for whatever reason, want to issue them a credit. And so store owners shouldn't be able to, issue app credits. And what happened here is, yeah, the admin page there, which I'm not exact. So the general issue here is this admin internal web GraphQL course. So this is, I'm assuming, kind of the normal place you're going to hit GraphQL if you're like a store owner. You're going to hit that page as like sending your GraphQL queries. But there's also this GraphIQL application that Shopify runs as like their own app that you can query. And using that application, that's where the vulnerability is. While that first endpoint, it won't let you hit the app credit create. GraphIQL will let you hit that endpoint. So it's just kind of a mistake between the privileges on both sides. One allows and one doesn't, and it shouldn't be allowed at all. I'm not sure who exactly would be using the GraphIQL application versus that actual endpoint, or even why this vulnerability would come up at all. Unless the GraphIQL is like a higher privilege user, but that shouldn't be exposed to admin. Like, it should be impersonating a user. Like, you should be needing to provide some sort of authentication that it then uses. I haven't looked into how it actually works, but it does seem like a very weird bug to have this sort of inconsistency.
Yeah, I'm not gonna lie. When I read this issue, I understood the vulnerability. Like the vulnerability is really straightforward, but the scenario, I I was like, why. It just seemed weird to me.
Yeah,
Um,
like it. So I missed the fact that it was GraphIQL app that was the vulnerable one. So I think that's probably a key point here. Is that it's like a separate app that wraps GraphQL, but it's still that it still seems like a very odd one to have. Like you'd expect consistency because in theory you're querying, I believe, the same GraphQL database. Like it should be the same backend, I would imagine. So yeah, it is a weird vulnerability. Straightforward though. One endpoint allows one thing and the other doesn't.
yeah.
And
The
a
impact there,
2,900 bounty, $100 bounty.
yeah. And that's because the impact there is like fairly significant, because you are able to just create like an infinite amount of application credits if you took advantage of the attack. And the researcher was very happy with the $2,900 bounty payout. If you look in the comments, they said they were that's the highest bounty that they've received for a medium impact issue, and they really liked working with the Shopify triage team. There wasn't a ton of back and forth there. It was fixed pretty quickly within a week, and that's probably just because of how simple uh, the issue is, especially if you understand the scenario, which I don't really. But for them, yeah, it was an easy fix, so they fixed it quickly. It was reported July 11th, and it was fixed July 15th. So, but yeah, it was cool to see that there was the little bit of back and forth that was there between the researcher and the Shopify triagers. Um, yeah, it was good. The researcher was happy with the communication. So, because we've covered quite a few reports in the past where that hasn't been the case. So, it's nice to see when it goes the other way, and everyone kind of leaves happy after the report.
And I'll also shout that it was the Shopify side who did the first request to disclose. That's just a nice thing to see in general. I mean, Shopify's really active. They maybe it's not a good thing, but they've had a lot of vulnerabilities reported against them on HackerOne. They tend to disclose them. Generally, just all around, they seem like a pretty solid program.
Yeah. All right, so we'll get into our last topic of the episode, which is our research topic from Palo Alto Networks, and it features two container escapes in Azure Container Instances, which they kind of take that named vulnerability route and call it Azure Escape, which they also note is the first
Very
cross
creative
account.
name.
I know it's very they put a lot of time into that, I'm sure,
That is a name Ball I can kind of get behind.
just
Um,
because of the simplicity of it.
yeah, I mean, you know what you're talking about.
Yeah. Yeah, I mean, we won't go into that discussion too much, but the one point that you've always tried to hammer home with named vulnerabilities is they should convey the point quickly. It shouldn't be some weird convoluted thing where you have to research into why they named it that. So yeah, simple, but it does the job. Um, they also note that this is the first cross-account container takeover in the public cloud, at least that they're aware of. So that is kind of a milestone with the post as well. First, they go into some background on Azure Container Instances and how they're set up internally with Kubernetes clusters. They detail the idea of multi-tenant environments where each tenant is a worker node that connects to a master node hosting the API server.
And
They have some useful diagrams there that help convey the point.
one thing
Go
to
ahead.
jump in quickly is just that this vulnerability only impacts the uh, Azure containers that are running on Kubernetes clusters. So some of the containers will be run on Service Fabric. Those aren't vulnerable to the same thing. So it is worth pointing out. And part of the fix on this one ultimately was just moving away from Kubernetes in general. I think they said now it's like 10%.
Yeah,
So I just wanted to call out that aspect. We're not talking
yeah,
about all containers everywhere as being vulnerable here, all Azure container instances.
yeah. It's a good thing to keep in mind when we're covering the issue. So yeah, they cover like how the multi-tenant environments work with Kubernetes, and that's where their attack scenario is. A malicious tenant that's able to break their node's uh, boundary to take over the API server and in turn get control over all the containers that run in that cluster. Their first attack that they detail consists of two issues. one of which was an end day due to outdated software, and the other was a powerful GWT token leak. Um, when they were investigating the image, go ahead and see.
Yeah, usually like the end days, I tend to like, oh, it's an end day, and I tend to skip over a lot of details. But they talked about this thing called Husi, which is a container that they created. They unveiled it just at DEF CON back in August. And I think it works in kind of a really cool way. And that's how they so figuring out that they could even use the end day in the first place, they need to know what's running. So this was how they basically figured out that inside of their containers, what was the platform that it was running on, and this was runc version 1.0.0 release candidate 2. Um, so in figuring that out, what they did was this whoc container they built effectively ends up just reading its own, or actually it sets its entry point for the container to its own proc self exe. So it executes itself inside of itself, and before doing that, it'll replace its loader. So the loader will basically just disclose like the entire binary and send it wherever you want. I just think it's a really cool trick to find that information. They've packaged it up. They've got the GitHub with it and stuff. You can read more about it. They have a version that works without the loader too, where if it's statically compiled, and they go into those details. I just thought it was a really cool trick to finding out the service that's actually running the container.
Yeah, unfortunately, not one of the DEF CON talks that we covered. That said, I might go back and just check out the talk, just with how interesting it sounds like it is from this article. So maybe I'll do that later on. But yeah, like you said, they use their whoc image um, to scope out the environment of the container runtime. They found the version for Run C, which was version 1.0.0 release candidate 2, which is pretty incredible because that version was released in 2016. It's a very old version. So any bug that's been discovered since then that hasn't had like a backported fix could potentially be used to escape the container to the Kubernetes node. They use CVE 2019-5736, which they did a previous blog post on for breaking out of Docker containers. They basically just ported that POC straight over and used it on Azure Container. Now at this point, they are still isolated to that node in the multi-tenant environment. They haven't broken that boundary yet, but they do
Yeah,
have a lot
so
more wiggle room and attack surface to work with.
like for the listers, I mean, basically the idea here is you have like your one server, your cluster actually. And the containers they're running inside of VMs, yet inside of that cluster, um, they've got a VM, and then inside the VM, the container runs. So in theory, you have to do the container escape, you have to do the VM escape, and then you can start attacking other things.
Yeah. Um, so Yeah, they have a lot of wiggle room and attack surface, even though they're still isolated to that node. One of the things they could do, for example, was they could scope out the node environment by using the kubelet credentials to list the pods and the nodes in the cluster. They weren't actually able to access the nodes. There was like an anonymous access capability, but there was some firewalling in place that would prevent the cross node access in that way. Um, and then after using kubectl to see the Kubernetes version that was running, which was one of three versions that they list, which were all like fairly older, like 1.8.4 to 1.10.9. Um, they wanted to see if they could do the same kind of attack where they could use an end day and take advantage of that. They focused in on CVE 2018 1002102, very long CVE identifier, by the way.
Yeah, I
Um,
noticed that, and I
it was weird.
don't know why, because like I thought, okay, maybe 2018 just had, like over a million CVs, but I'm not sure that's the case either.
Yeah, I don't think I've
Like,
seen a CVE identifier that long before.
no, because I remember when they like officially made the statement about like extending the identifier by a digit, but not this long. But like that is the actual CV. At first, I thought it was just a typo, but like no, that's the CV number. Oh no,
Yeah, I
weird.
wonder what
I'm
the
not
story
sure
is behind
why,
that.
but it's also another cool. This one on the end day side, it's kind of a cool little attack too. Um, I straightforward, basically just pointing it to the wrong, or when the API server makes a request to your kubelet, you can reply to it and be like, oh, this request actually, give it a 302 header and redirect it somewhere else, and then it'll go to another container and try and execute the same thing. So if you can cause like an exec, you can redirect it to another container. A little attack too,
Yeah.
even though it didn't end up working here.
So they tried to use that to send redirects to the API server, because that is like their ultimate target through all this. But like Z was saying, they discovered they couldn't ultimately exploit this because the requests weren't coming from the API server; they were coming from a bridge node, which had a backported fix for the bug. It wasn't all for nothing though, because while they were trying to get that exploit to work, they discovered the exec request from the bridge contained an authorization header, which included a Kubernetes service account token. And this token had the pod's exec privilege to the API server, which would allow anyone who could use this token or who owned this token to execute commands on any pod in the cluster, including the API server itself. So by taking over the API server, you now have full control over any tenant in the cluster because all the tenants will communicate with the API server. So a very cool and impactful attack chain. There was also a second attack that they discovered after they submitted the first one, I believe, um, which was a server-side request forgery in the bridge pod. Basically, when the bridge constructs the request for an exec command from a pod, it takes the node IP from the customer pod's status.host IP field. Now, the API server would try to correct that IP field after a few seconds, but you could just continuously overwrite it and kind of race against that correction. Um, Now, this in itself, like being able to control the host IP field, wouldn't have gained attack or anything immediately because the URL would still point to your pod's namespace, even if the request was sent to a different pod's IP. So it would just kind of be ignored. But they found a more serious issue in the way that the host IP field wasn't even validated to make sure that it was a proper IP address. You could set it to any arbitrary string, which could include URL components. So that gave you an injection into the request URL, which you could use to trick the bridge into executing a command on the API server container instead of your own, which gives the same kind of impact as the first attack did. Same compromise. You can compromise the API server. You can compromise the entire cluster. So yeah, very very impactful attacks, both of them.
Yeah,
Um,
impactful and I mean kind of cool. I mean, just one the who see thing. I love that little trick. Uh, thing that the redirect, like even the failed one, like I think there's just a bunch of really cool tricks in this that they were able to use.
yeah, this is one of those posts where I feel like nothing was wasted. They do go into like quite a bit of background detail, but there was nothing that I felt was like fluffy or anything like that. Like I felt like everything was relevant. They do a really good job of explaining the issue because that's one thing with cloud. Like I've always found cloud issues kind of interesting, but so many of the posts that cover them, they assume some kind of prior reader knowledge or prior familiarity with the area. And cloud is just not really something that I do. So being able to read this post and having it accessible to me as somebody who doesn't do things in the cloud, um, I just really appreciated that from the post because it's not something I see in a lot of posts that cover the cloud. So I wanted to call that out because if any of the readers out there have found what we've covered interesting and want to read the post, it is a very accessible blog post for that. So, um, but yeah, Z, I don't know if you have anything else you wanted to add on to that, but
Nope.
if not, we'll move into our shoutouts. All right, so you can cover this shoutout because this is
Yeah.
something that you added. So
One I added, I just came across this while looking for topics, and it is a I am vulnerable in AWS IAM privilege escalation playground. I haven't been able to play around with it at all. I'm not sure everything that's covered in what type vulnerabilities comes from Bishop Fox Labs. Generally, really good content, so I'm expecting good things from this. So I'm recommending it without having actually played with it too much. But that disclaimer aside, looks cool. And I mean, AWS, like identification and all of that, it is a really annoying area. It's really easy to get it wrong. We actually were going to cover a different vulnerability this week that was in some IAM issues. So I mean, it's one of those areas that I haven't seen any sort of practice environments to actually look for and try and find any sort of issues. But I think this it's promising if you want to look into those sorts of cloud vulnerabilities that aren't just like your standard exploits, but are very specific to the cloud environment.
All right, cool. Before we head out, I'll just quickly point out for the listeners who can't see the chat. Um, the long CVEs, Brutamol pointed this out. The long CVEs seem to come from collisions, so that explains why the identifier was so long. But thought I'd just call that out quickly for anybody who uh, watches this after the fact. But yeah, that pretty much concludes all the topics that we have for this week. Thank you to everyone who tuned in. You can catch the VOD on Twitch or on other platforms like YouTube and Anchor 24 hours after the podcast. We will be back again tomorrow with our binary episode. That is at 7 p.m. Eastern. And that is also where we'll be covering the Spot the Vuln challenge, which we had up on the pre-stream. I think we'll also put that in the Discord as well. For those of you who haven't, you can check out our Discord as well. I'll quickly link that in chat for anybody watching. That is also down below in the video description and also at the bottom of the page on Twitch. But yeah, with that said, we will see you all tomorrow on the binary episode.